In this problem we have two people, Jen and Dan, and they put their money together, and total they have 13 $1 bills represented here. So the total contribution is going to be $13, and what we need to do is come up with different ways that this could happen by showing what Jen's contribution, or what she gave, is right here, and what Dan gave, or his contribution, right here. So these two numbers put together have to make 13. There's many ways this could happen, but we need to only determine 3 of the possible amounts they may have originally had if each contributed or gave at least $2 and each gave a different amount. So I'm going to start by dragging these dollar bills, but then I'm going to show you that you need nothing more than a pencil and paper to learn the concept that's working in this problem. Remember that it said that each gave at least $2. So that means Jen must have contributed at least 2 of the dollars, and Dan must have contributed at least 2 of the dollars. So now we're up to $1, $2, $3, $4. So the amount remaining, we can simply drag the rest over. Don't forget that the other condition is that each person gave or contributed a different amount. So for example, right now I have Jen contributing $3 and Dan giving $3. So this would not be a correct possibility. One person has to give more than the other. And if you continue just dragging these over, so this would be a case where each person gave at least $2, and they gave different amounts because Jen gave $1, $2, $3, $4, $5, $6, $7, $8. The important thing to know is then that whatever Dan gave, $8 plus what Dan gave has to equal 13. So putting things together to make a whole is what we call addition. 8 plus this mystery number, you could put a question mark if you wanted, have to equal 13. It's also important to know the relationship between addition and subtraction. Jen's contribution plus Dan's contribution has to equal $13, so that means since there's $13 total, another thing you could say is that if you took the whole amount, the $13 here, and took away the $8 that Jen gave, that would have to give you the remaining amount, which is what Dan contributed. So that would be the question mark here. So addition and subtraction are related in this way. Two parts added together gives you a whole, or you could think of it as if you took the whole, that's all of these, and took away part, that would leave you the remaining amount. The way I've set this up though, you can see that to get the amount that Dan contributed, you could simply count the remaining amount. There were 13 to start with. Disregarding the 8 that Jen already gave, leaves me the amount that Dan gave here, $1, $2, $3, $4, $5. So it was really fun and visually appealing to drag these dollar bills around the screen, but it's important for you to realize that the concept involved in this problem could be easily described by just using pencil and paper. Since we want the contributions to add up to $13, you could simply make 13 marks on a piece of paper. So for example, here are my 13 not so visually appealing marks on the paper, but the important thing is that there are 13 of them. So this represents how much money there will be after Dan and Jen give all of their dollar bills. So in the last example, I decided that we would have Jen contributing way more than Dan, let's say 8. So that would be 1, 2, 3, 4, 5, 6, 7, 8. The neat thing about setting it up this way is it's more visually obvious that if you took the 13, which is all of them, and you were to remove 8, as was the case when we supposed that Jen gave $8, you could see that if you took the whole amount, the 13, and took away the 8, once Jen gives her 8, what would remain is Dan's contribution, 1, 2, 3, 4, 5. Again, it's important you to see that you could think of this as an addition problem or a subtraction problem. So the idea is that there were $13 to work with, and what we did is we took those $13 and just gave an example where we supposed that 8 of them were Jen's contribution, and once we took away 8 of them, there were 1, 2, 3, 4, 5 remaining. Now you don't have to think of it this way, especially if you haven't gone on to subtraction yet. But it can be also thought of as an addition problem, meaning that there's different ways of breaking 13 into two pieces so that those two pieces add together to give 13. So you could think of it as these 8 pieces added together with 1, 2, 3, 4, these 5 pieces have to make the 13. So $8 added to 5 more give 13. Well, we can just circle a different amount of the 13 and come up with different combinations. You have to remember that one of the things that has to be true is that each gives at least $2. So I have to circle at least 2. So for example, if I circled just 2, that would be fine. But if Jen only gave $2 and the total is 13, remember that Jen's contribution plus Dan's contribution has to come out to be 13. So if this is Jen's contribution, the remaining amount here must be Dan's contribution. Again, you could think of this as addition or subtraction. Jen's amount plus Dan's amount has to total to be 13. The other way to think of it is there's $13 to work with, so if Jen contributed 2, the remaining amount, meaning 13 take away 2, would be the amount that Dan contributed, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You might notice that it's easier, rather than counting 11 of these, is to say there were 13, so if I took away 2, that would be 13, take away 1 would be 12, take away 1 would be 11. It's faster to get to the 11 using subtraction than it is addition. But what's more important is that you realize that both are equivalent. We do have to come up with a third way, so this time I won't circle 8 or 2. I had to pick a different number, but it has to be at least $2. So let's suppose I pick $4 this time and say that Jen gave $4. Then that means that Dan must have contributed the remaining amount. And again, you can do this by simply adding, because 4 plus this number has to give me the total of 13. So what would this number be? 1, 2, 3, 4, 5, 6, 7, 8, 9. So Dan must have given $9. So Jen's contribution of 4, together with or added to Dan's contribution of 9, gives you the whole amount of $13. You might see this as an equation: 4 plus 9 equals 13. If you're familiar with subtraction, you could have done it another way. You could have said that the entire amount is 13, and then we'll consider that $4 came from Jen. So if the entire amount is 13 and 4 was from Jen, if you took the 13 and just took away the 4 that Jen gave, you'd be left with the remaining, which is how much Dan gave. So that would look like 13 take away 4, which would be 13 of them. Taking away the 4, you could count down 12, 11, 10, 9, and you could get to the answer here that way rather than adding the individual numbers. In fact, you could even go so far to say that if you had 13 to begin with and you wanted Jen to give 4, you wouldn't even have to write the 9. You could simply say there's 13 total, and I'm going to disregard or take off the ones that Jen gave. So you started with 13, taking these away would be 12, 11, 10, 9, and then you'd been able to tell what Dan's contribution was.